given some numbers, can you find subset of them with zero sum? Well, sounds easy. For a given example, we can just take 2 plus 2 plus minus 4 equal to 0. But is it really all that easy? Let's consider a bigger example. So in this case, there isn't any zero-sum subset. But maybe if we just change one digit in the first number, oh, there is one and pretty and almost impossible to find subset we need. Simple solution be like brute force all possible subsets and find numbers that add to the ends of them. It turned out, with all the optimizations and tricks humanity have developed, the best algorithm we have is of 2 to the n over 2 complexity. That is, for 100 numbers, we have to wait 180 days. And for 200 numbers, we have to wait 4 trillion centuries. For comparison, it's only 138 million centuries since Big Bang. But with all those information talked, the point of this video is completely another. What I really want to show is how small feature can dramatically change problem. And even more important, how new solution can be freaking out of the box. So, let's come back to our problem and add one more thing. We have n numbers, and we want to find zero-sum subset modulo n. And I want to do that fast, and I want to prove it is hell always possible. Let's look at small example. So we have 4, 5, 5, 3, 3, 5, and we need zero-sum subset modulo 6. One of the solutions is 5 plus 3 plus 5 plus 5 equal to 18, which is equal to 0 modulo 6. But there are other solutions like 3 plus 3 equal to 0 modulo 6. Now you can pause video and think how you would solve this problem if you are given million numbers. Looks like problem is number theory one, particularly modulo part, which is decoy, and problem is all about graphs. Go back to our example and let's do next steps. For each number, imagine it's a node of the graph. Then, create an edge from this node to the node that is corresponding number positioned next. So we start with the first node, and we create an edge to the node that is 4 positions next to it. That is, we create an edge to the 5th node. Then, for the second node, we move 5 positions forward. If we go out of bounds, we start from the beginning. So we create an edge from the second node to the first node. Same for the third node. For the first and 5th nodes, we move 3 positions forward. And again, if we go out of bounds, we start counting from the beginning. And for the last, we create an edge from the 6th node to the 5th. So we get graph with n nodes and n edges, each node having one outgoing edge. Do you spot general solution now? Well, what if I highlight something? Solution of this problem is to build graph as explained before and find any cycle in the graph. On the shown example, we have cycle that consists of nodes with numbers 4, 3, and 5. If we add 4 plus 3 plus 5, we will get 12, which is equal to 0 modulo 6. To prove our solution is always correct, we have to show two things. First, we always have at least one cycle, and second, why numbers in a cycle give correct solution. To find a cycle, we can start at first node and move by edge until we visit some node second time. Every time we move by edge, we either find cycle or decrease number of unvisited nodes by 1. As number of nodes is finite, we can't infinitely discover new nodes, so we will visit some node twice, and thus we will always find cycle. Now we go to why cycle form solution. Let's see what actually happens in the given example. We start at first node, then move by 4 positions, then by 3, and then by 5, and we come back to the first node, everything modulo 6. If we remove 1 on both sides, we will get zero sum. In general case, we have cycle of length k, so we start at some position L, then for each node of the cycle, we move by corresponding number of positions, and then we come back to the node L. If we remove L from the both sides, we will get that all the numbers in the cycle sum up to 0 modulo n. And that's basically it. As a conclusion, we not only prove it is always possible to find zero-sum subset modulo n, but we also propose fast linear time algorithm to do that. Hope you like solution and graph-based approach. If so, please like this video and subscribe to the channel for the future updates. Bye!